This is a short video for analyzing ZooMS Spectra using the open source program mMass. You can download the program following the link on the screen. We already have the text files which are compatible with mMass and which were converted for us from the multi-files with an R script. Following the sample information on your plate map that you filled when spotting the samples onto the multi-plate, open the 3 text files of one certain sample. As an example, we use sample number 2, which means that we open files number A2, A5, and A8. After opening the files, check the spectra one by one. Since they all look okay, we can use all 3 and average these. For example, if one of them would have looked failed, a messy spectra with no real peaks, we would not include that one in the average. To average the 3 spectra, make them all visible again. Click Data Processing, Math Operations, Average All Visible, Apply. Now uncheck the single spectra. Double-click on Average Spectra, rename it with your sample name, and this is now the spectrum that we continue with. Now we select Crop Data, make sure that low mass is on 800, high mass 3500, click Apply. Then, to check if our peaks are fine, we now open Peak Picking. We have the signal noise threshold set at 12. All other values remain as they are, and click Apply. This could take a few moments. To zoom in the spectrum, right-click and drag on the spectrum. We can see the red line as the threshold that we set. Anything below the red line is noise, and anything above the red line would be a peak. Double-click the spectrum area to get back to the full view. Now you can close the small window. And on the right, we can see the values for the existing peaks in our sample. And now we can start comparing our peaks to the published data. For that, we use the table made available by BioArc, University of York, containing markers for a list of taxa. We start with a peptide named P1, which in our sample is barely visible, but there is a peak with a value of 1105 there, and so we can filter it out in the table and make the possible list of taxa a bit shorter. Next, we move on to a peptide named B. Here, for example, we can see 1453, which in our sample is nicely and clearly there, and we can filter it out. Then we move on to a peptide named D, 2131, again nicely and clearly visible in our spectrum, and we can filter it out. This makes our possible list of taxa quite short now. Let's move on to the high mass part of the table. For example, here 3033, which is clearly here in our sample, and which we can filter out, which gives us now the option between alpaca and a pig. Moving here, 2820, 2883, we can see that both of them are clearly here in our spectrum, leaving us the result of pig sus domesticus. If identification is completed, copy the Excel table with filtered values to your own results file. Make sure to include only those values that you actually have the peaks for. Also, remember that not all those columns need to be checked when you're analyzing a spectrum, but also remember that identification cannot be based only on one peak, so do check several ones. In the end, save your mMass file with a sample name and your result. And this is how your spectrum is analyzed.